Welcome back to Java Internals Crashcasts. I'm Sheila, and today we're continuing our journey through the fascinating world of concurrent collections. We're in the third season, focusing on concurrent collections, and we're exploring the queues chapter. Last time we discussed ArrayBlockingQueue, and now we're moving on to LinkedBlockingQueue. Victor, are you ready to dive in?
Absolutely, Sheila. I'm excited to explore LinkedBlockingQueue with you and our listeners. It's an important implementation of the BlockingQueue interface that we covered earlier.
Great. Before we start, let's pose a quiz question to our listeners. Here's the question. What's the key difference between LinkedBlockingQueue and ArrayBlockingQueue in terms of capacity? Think about it, and we'll reveal the answer at the end of the episode.
That's an excellent question, Sheila. It really gets to the heart of why we might choose one implementation over the other. I'm sure our listeners will find it intriguing to consider the implications of capacity differences in these two queue implementations.
Now let's start with the basics. Victor, can you give us an overview of what LinkedBlockingQueue is and its core properties?
Certainly. LinkedBlockingQueue is an optionally bounded blocking queue implementation based on linked nodes. It follows a FIFO, first-in, first-out ordering, just like ArrayBlockingQueue. The key difference is in its structure. It uses a linked list internally rather than an array.
Interesting. So when you say optionally bounded, what exactly does that mean?
Great question. It means that when you create a linked blocking queue, you can specify a maximum capacity, but you don't have to. If you don't specify a capacity, it's essentially unbounded, limited only by the available memory in your system. This is in contrast to ArrayBlockingQueue, which always requires a specified capacity.
I see. That sounds like it could be both an advantage and a potential risk. Can you elaborate on the implications of this?
Absolutely. The flexibility of an unbounded queue can be advantageous in scenarios where you don't know the maximum number of elements in advance. However, it also comes with the risk of potentially consuming all available memory if not managed properly. It's crucial to consider your specific use case and system constraints when deciding whether to use a bounded or unbounded queue.
That makes sense. Now, let's talk about the blocking operations. How does LinkedBlockingQueue handle these?
LinkedBlockingQueue implements the blocking operations defined in the BlockingQueue interface. This means that when you try to add an element to a full queue or remove an element from an empty queue, the operation will block until it can proceed. For example, the put method will block if the queue is full, and the take method will block if the queue is empty.
I think an analogy might help our listeners visualize this. Could we think of LinkedBlockingQueue as a line of people linked by a rope, where people can join at the back and leave from the front?
That's a great analogy, Sheila. Imagine a line of people waiting to enter a popular attraction. Each person is holding onto a rope that connects them. New people can join at the back of the line, on queue, and people at the front can enter the attraction and leave the line, DQ. If there's a maximum capacity, no new people can join once that limit is reached. They have to wait until someone leaves. And if the line is empty, anyone trying to enter the attraction has to wait until someone joins the line.
That really helps visualize it. Now, let's talk about performance. How does LinkedBlockingQueue compare to ArrayBlockingQueue in terms of performance?
LinkedBlockingQueue generally offers better performance than ArrayBlockingQueue, especially in multi-producer scenarios. This is because it uses separate locks for the head and tail of the queue, allowing concurrent access to both ends. ArrayBlockingQueue, on the other hand, uses a single lock for the entire queue.
Interesting. Can you give us an example of a real-world scenario where LinkedBlockingQueue might be preferred?
Certainly. LinkedBlockingQueue is often used in producer-consumer scenarios, particularly when you have multiple producer threads. For example, in a log processing system, you might have multiple threads generating log entries, producers, and a separate thread or group of threads processing these logs, consumers. LinkedBlockingQueue can efficiently handle this scenario, especially if the rate of log generation is variable or unpredictable.
That's a great example. Are there any common pitfalls or best practices we should be aware of when using LinkedBlockingQueue?
Absolutely. One common pitfall is assuming that an unbounded queue is always safe. While it can grow dynamically, it's still limited by available memory. It's generally a good practice to set a reasonable upper bound, unless you're certain that the queue size will remain manageable. Another best practice is to prefer the offer and poll methods with timeouts over add and remove. This allows you to handle full or empty queue scenarios gracefully without indefinite blocking.
Those are valuable tips, Victor. Now, before we wrap up, let's reveal the answer to our quiz question. The key difference between LinkedBlockingQueue and ArrayBlockingQueue in terms of capacity is that LinkedBlockingQueue can be optionally bounded, while ArrayBlockingQueue is always bounded.
Exactly right, Sheila. This difference in capacity behavior is crucial when choosing between these two implementations for specific use cases.
Thank you, Victor, for these insights. To summarize, we've learned that LinkedBlockingQueue is an optionally bounded blocking queue based on linked nodes. It offers separate locks for head and tail, making it efficient for multi-producer scenarios. We've also discussed its blocking operations, performance characteristics, and some best practices. In our next episode, we'll be exploring Priority Blocking Queue, another interesting implementation of blocking queue. Stay tuned.
It's been a pleasure discussing LinkedBlockingQueue, Sheila. I look forward to our next topic.
Thank you all for listening to Java Internals Crashcasts. If you found this episode helpful, please subscribe to our podcast and leave us a rating. Your support helps us continue providing valuable content. Until next time, happy coding.